we have here 1, below 1 we have 6, that's why it's 1, 6. 2, below 2 we have 7, that is why it's 2, 7, and then 3, 3, this is the 3, and then below 3 we have 8. So we have 3, 8, and then 4. Below 4 we have 1, that's why it's 4, 1, and then 5. So below 5 we have 2, which is 5, 2. Then 6, below 6 we have 3, which is 6, then 3, then 7. So below 7, which is 4, that's why it's 7, 4, and then 8. Below 8 we have 5, that is why it's 8, 5, or it is equal to alpha sub 3. So for example, we have alpha sub 1 star alpha sub 1. So here is 1. So 1, first, it's below 1 is 8, or here is 8. So below 8 we have 7. That is why it's 1, 7, because here is the 1. So below 1 it's 8. So here is the 8. So it's 7. So 2. So below 2 is 1. So here is the 1, and below 1 is 8. So 2, 8. Then 3. So below 3 we have 2. So here is the 2. Below 2 is 1. That is why it's 3, 1. And then we have 4. Below 4 is 3. So 3. Then below of 3 is 2. That is why it's 4, 2. Then 5. Below 5 is 4. So 4. Here is the 4. And then below 4 is 3. That's why it's 5, 3. Then 6. Here is below 6 is 5. So 5. Here is the 5. So below 5 is 4. So 5 or 6, 4. So next is 7. Below 7, we have 6. So below 6 is 5. So 7, 5. Then 8, 7. So here is the 7. And then below 7 is 6. That's why it's 8, 6. So that is equal to alpha sub 2. So for alpha sub 2 star alpha sub 1. So as you can see here, we have 1. So below 1, we have 7. Then we're going to look at 7. Then below 7 is 6. That's why it's 1, 6. 1, 6. Then 2, below 2 is 8. So we have 8 here. Below 8 is 7. That's why it's 2, 7. Then 3, we have 1. So below 1, we have 8. Is 3, 8. And then 4. Here is 4, and then below 4 is 3. That's why it's 5. Okay, 6, 3. Okay, 4, 1, then 5, 2, then 6, 3. Then 7, we have here 5, and then 5 is 4, so 7, 4. Then for 8, we have 6 is, this is the 6, and then below 6 is 5, 2. So 8, 5. So it is equal to alpha sub 3. So to summarize that, here is our permutation group. So it's 256 elements in total. So the results are in the color red. So let's prove that our permutation group is a group structure. So again, we need to satisfy these conditions. It must be closed, it is associative, it has identity element, and it has inverse element for all. So for first one, is it closed? So since all resulting elements from the operations are contained within the set, so it follows that our geometric model is closed under operation store. So we already proved that it is closed. Next one, for our next condition, is it associative? So to verify the associativity of our results or of the permutation group, we need to rotate it 180 degrees. So here, So for better illustration, here is the rotated table or permutation group. So we need to do necessary changes to columns and rows so that it will be the same to our original table. So for first one, we need to interchange column 2 and 8. Next, we need to interchange column 3 and 7. Next, we need to interchange column 4 and 6. Next, we need to interchange column 9 and 15, column 15. And then we need to interchange column 10 and 14. And then we need to interchange column 11 and column 13. So as you can see, if we're going to do those changes, it will result like this. So therefore, we prove that it is associative because our results are the same with our original table. Next, does an identity element exist? So an identity element exists because there's a value a sub 0 where the row and column meet that follows the same order. So as you can see here, this here is the same, this row is the same with this column. Okay, so a sub 0 is the identity element. Next one, does an inverse element exist? For all elements, so we have here a sub 0. The inverse of a sub 0 is a sub 0. Then the inverse of a sub 1 is a sub 7. The inverse of a sub 2 is a sub 6. The inverse of a sub 3 is a sub 5. The inverse of a sub 4 is a sub 4. And the inverse of a sub 5 is a sub 3. Then the inverse of a sub 6 is a sub 2. And then the inverse of a sub 7 is a sub 1 or alpha. Okay, so beta sub 1, the inverse of beta sub 1 is beta sub 1, and beta sub 8 is the inverse element is beta sub 8, and the inverse element of beta sub 7 is beta sub 7, and the inverse of beta sub 6 is beta sub 6, and the inverse of beta sub 5 is beta sub 5, and the inverse of beta sub 4 is beta sub 4, and the inverse of beta sub 3 is beta sub 3, and then the inverse of beta sub 2 is beta sub 2. So therefore, the permutation group forms or holds a group structure because it meets this following condition. It is closed, it is associative, it has identity element, it has inverse element for. Okay,